question 46 is our first look at a reducing balance depreciation table. Now, please notice it's 20% each year. So the value at the start of the year times 20%. Now, if you do that, that's 5,700. And the value at the end of the year will be less the depreciation. So the start of the year, the 22,800. Now, when we multiply that by 20%, we'll get $4,560. So the amount of depreciation you get with a reducing balance scenario is quite high at the start and then drops off. So this has a different purpose or perhaps outcome to what a constant or fixed price straight line depreciation scenario is. So the 18,240 starts the next year. I multiply that by 20%. Do the addition, to the accumulator, and then the subtraction for the value at the end of the year. Now I'll just pause the tape and finish off the rest of the table. So you can see now the completed figures. There is a bit more work in doing these calculations than what there are with the straight line, as it's a new depreciation figure each year. Now I want to check that using a suitable formula. P lots of 1 minus O to the power of n. And when I do that, you can see pretty quickly that the last figure at the end of the 6 years and that and the formula match. Now, what I've now got to do is to graph the value of the vehicle against its age. So I've got the data there, and we're doing that for 0 is the value we bought the vehicle for. Now notice here, it's going to be very hard to exactly fit the points, so good estimates required. So the value at the start of 0, the value after 1, the value after 2, the value after 3, 4, 5, and 6. And you can see here that this takes a bit of an exponential tumble down the line. Where we make use of reducing balance the best is when we want to get an early return from our tax. So starts off quite steep and then shallows out. Now that will never ever reach 0. We'll get very, very close to it. So we'll reach a final figure that will be a scrap value that is not 0.